In this video, we're going to have a look at proteins. But before we do that, we need to have a look at the structures, which are the building blocks of protein. You'll notice that the amino acid has a carboxyl group and an amine group. It also contains a R group here. So this is what makes amino acids different from each other. They all have but this side chain here can vary. Now, in terms of you dealing with amino acids and drawing structures of proteins and such, this central carbon here is probably the most important. So the alpha carbon, you always want to look out for in a structure. So you want to look out for this carbon, which is between the carboxyl and the amine. The reason why this is so important, in protein chains, you want to line your amino acids up end for end. And to do that, you'll need to identify this central carbon. I'll come back to that later. Just now, I'm going to have a look at how you join your amino acids together to form a protein chain and draw the structure of that chain. So basically, what we've got going on here is a series of condensation amide functional groups. So nothing new, you've already looked at those. Basically, we're taking the hydrogen from here and the OH from there, and they are going to form H2O, which will fall out of the structure. And then that nitrogen is free to bond with the carbon. So you'll see we've now got an amide group linking those two units together. Now, I haven't completed the unit yet. I've got to the nitrogen, which is here, and we can see we're going to have the same here where we get an amide form between that amine and the following carboxylic acid. Oh, sorry. Now we can see here I've left the end of the chain open, or I've indicated that it's left open with the dotted line. What that shows is that the structure continues on. That's important when a section of a larger structure, which a protein chain generally is. So it's important when you're drawing just a section of the chain, one or both ends open, to show that it continues on. You can see in this case I've left the right hand end open to say that the chain continues on in that direction, whereas on the left end here it is just the end of the structure, so that would be the end of the chain. So you've seen how easy it is to draw a section of a protein chain by linking together individual amino acid groups with a amide link. However, you won't always get the structures drawn in such an easy way to recognize, and it's very, very important that you identify those structure. So that is the carboxyl, the amine, the side group, and that alpha carbon. So you recognize those features so that you can redraw your configuration. Once you've got your structure drawn in this configuration, it's really easy to draw your protein chain. So for example, in this structure here, a common mistake that people might make is going, okay, there's my carboxyl, there's my amine, and try to draw their protein chain by end for end joining multiple units of that structure. But what you notice is our basic amine structure, where between our carboxyl and our amine, we've only got one carbon, whereas in this case, a really long chain. Done is incorrectly identified our appropriate amine group. So if we go back and we actually look for our alpha carbon, the carbon which is bonded to our carboxyl, it's got one hydrogen, and then it's bonded to our amine. So what we notice then is that this component here is actually our, so we want to redraw this structure in this configuration. So we draw carbonyl, and this is the same for every single amino acid. So you're always the same. The only thing that's going to be different is your side group. So this first part is really easy. And once we've identified our side group within the structure, it's just a matter of copying. So now we've got our carbonyl and our amine. So you can line those molecules up now and join them together using the condensation reaction to get your structure of your protein, with this group being the side chain. I can't stress how important this is, as trying to draw the protein chain using that structure and the incorrectly identified, one of the most common mistakes I see in students' tests to do with this part of the course. Now within a protein chain, you need to be able to identify the amide group. So what you're looking for is your nitrogen bonded to your carbon, your hydrogen and your oxygen out each. So you should be easily able to identify that amide group within the structure. It's also worth noting that in protein chains, that amide group or link is often called a peptide bond or a peptide link, and those of you that are doing biology would have heard that plenty of times before. Now proteins can be broken down into the constituent amino acids, and you need to be able to draw the structures of the amino acids which make up a particular section of protein chain. So the way that you do that is you recognize your amide group, and we're just going to split between the nitrogen and the carbon in that amide group. So this is going to be the same sort of process that you do when hydrolysis of amides. So basically we're going to be adding a hydrogen on in that side, hydroxyl on in that side. And when we get to the other end here, we're doing the same thing again. So adding a H onto our amine and an OH onto our carbonyl. And so what you end up with is individual amino acids forming your protein, where it will be this side chain, which is ultimately different between the different components. One last thing I want to look at the moment is the ability of an amino acid to self. And when an amino acid self-ionizes, it leads to a type of structure called a Zwitter ion. So what's happening during this process is that the carboxyl group is acting as an acid as such to donate a proton, and the amine as a base and accepts the proton, which joins on here to. And what happens is a negative ion and a positive ion within. Now, despite there being a negative ion and a positive ion, or a negative charged and the overall molecule is neutral. And that essentially is what a Zwitter ion is. It's a neutral molecule that contains both a negative and a positive charge. And a amino acid is able to do that due to its ability to self-ionize.